Hi everyone, this is a tutorial about camera matching using accurate survey points. We're going to be using Syntheyes and Cinema4D to camera match a single photo using these points. Syntheyes is generally used for film and video, but it has some useful tools for helping us match single images for use in architectural visualizations. We need to do a bit of prep work beforehand before we go into Syntheyes. And here is the original plate with the marked up survey points which we got the surveyor to accurately survey, but Syntheyes needs a corrected, or rather a distortion-free image. Normally it can calculate that on its own, but with any one image it can't do that, so we'll do that ourselves. So we just run this through the camera raw filter, and knowing the what camera is used in the lens, the camera raw filter does a good job of removing the distortion. So from survey point to corrected, and this is what we'll feed into Syntheyes. We also need to prepare the survey data. Syntheyes needs it in an X, Y, Z format with an optional name of each point, but most surveyors give you a northings, eastings, and elevation. So just switch these round, switch the columns round. And then I've cut and pasted this into Notepad, just because Syntheyes wants a basic text file with a tab delimited between each entry. And it also needs a blank space, well, blank line at the beginning of the file. So once we've done those things, we can go over to Syntheyes. Before we even start, we need to alter one of the settings, one of the preferences, which is I think you'll just see that, edit preferences, and we need to change the axis setting to Y up left, which I've got changed here already. It makes a big difference. It doesn't. Once we've switched all the survey points around, it needs this to be changed to Y up left. And also, this is how Cinema4D reads the information as well. So that's important. So that's done. Now we can introduce the shot. So we will add shot, choose the file we want to use, the image we want to use, and the image comes. And now we need to make sure that everything's correct here. Pretty much everything we can leave as default. Just make sure your start frame and end frame covers the range of frames you're using. We can use more than one image. As long as we've got all the survey point data, you can do all this in one go, but we're just showing one frame at a time. So make sure that covers your frame range, 0 to 0, that gives us 1. And the next important bit is to give an accurate backplate dimension. So get your physical dimensions of your sensor size in here. If you can't find it from your manual or the manufacturer's website, go over to dpreview.com, and that's got a lot of information for pretty much every camera out there. So change that to I'm using a Canon 7D, so that's a 22.3mm wide sensor. So that's all good. Hit OK. Let's pull that in. Now we can bring in the survey points from our prepared file. So again, File, Import, and we're importing tracker locations. And here is that file. So that's brought them in. We can see that they're all listed here. If we go into the trackers panel, and I like to change the layout to camera and hierarchy. That way I can see all the trackers I've got here. So we'll go through each one of these, placing the tracking point over the feature that we had surveyed. So highlight the tracker point, and we need to hold the Z key down to place the or rather to move the tracker point. It's in here somewhere, but we don't know where. So hold the Z key down and just click once. Now we can take our fingers off the Z key and adjust this tracking point so it lines up with the feature that was surveyed. Once we've done that, we can lock it and move on to the next point. Hold the Z key down, click on where it's supposed to be. Let's just adjust the size of that feature. Move it into place and lock it. Now you don't want to watch me go through that whole process, so I'll pause the video here and come back to you when I've finished. So with all those done and locked, we need to make sure that they are all seed points, which you can't see in this panel, so we'll just go over to coordinates and we'll change that to camera and hierarchy again, and so we can see that each point is a seed point. So that's good. They should do that by default anyway, so there's no need to change anything. Now we need to lock all these points, or rather make the constraint a lock point. So we can either do them individually, or if you just click on the trackers it'll select them all. And then from unconstrained we can change those to a lock point. And as you can see, all the tracking points change to a cyan cross, indicating they're locked, or rather have a constraint on them. Okay, so we're good to go now. We can solve this. So let's go to the solver panel and we'll just run through this. So first things first, make sure that we're solving for this camera 01. The most important thing is change the solve type to from seed points. We also need to change the world size so it encompasses our largest coordinate, which was 800,000 something. So let's give that 1,000,000. 2, 3, 1, 2, 3. And that's it. Everything else can stay the same, even though we probably know what the camera and focal length is. We don't want to change that to known. We'll leave it at fixed unknown and let Syntheyes calculate it. Okay, so that's good. And so we can hit the go button. That'll happen pretty instantly. There's only one frame, so that's done. Hit OK. Now that's all looking pretty good. Top north is up the screen. That's all looking pretty good here. We can go to the change the layout to say constrain points, and we can see that IRAs are tiny. In fact, these are the inputs we got from our survey data. So the first one there, 406,604, 406. 400,603.9. I mean, everything is very close. So very happy with all that. That looks good. And all we need to do now is export that into Cinema4D. So to do that, we go up to File, Export, in this case Cinema4D Python. And we'll choose a location and file name. As you can see, I've done already, but we'll call that view 2 meters and save that. And here, the only things I've changed, leave everything as default, but the only thing I have changed is the relative tracker size. That'll mean the null points that come in Cinema4D defaults to a diamond shape on screen, and that'll be a reasonable size so you can see it. And the extra scaling, I've changed that to 100. There seems to be some factor of 100 that Syntheyes reduces the scene scale, so to compensate from that we multiply by 100. This is what's worked for me. It may be different in your software, so you might have to just export it a few times, make sure your scaling is correct, choose a different number in there. Okay, so that's that done. Okay, doesn't take long to export that out. So we'll go over to Cinema4D, and here's our ROS, survey plan, site plan, whatever we call it, brought in from, in this case, the local council's website. not fantastically accurate, but good enough for us, and we'll see where our camera points line up. Okay, so that's all there, and this is all in the correct dimensions. It's miles off the origin. This is 400. Let's highlight something, see what. So here we go. Here are our dimensions, and as you can see, they're all corresponding with our survey points. So now we need to bring in the survey points and camera from Syntheyes. So we'll do that via the script manager, and we locate that script, which was view 2 meters. There we go. And as I pointed in, looking through this, that's the script that Syntheyes generates. So we hit execute, and it brings all that in, sets the render dimensions to the same size as our photograph, locates the camera, and here are all our tracking points with a 1 meter diamond or anything fancy. So 2.1 is here, 2.2 here, and that's all looking good. Let's have a quick look in the plan view. As we can see, we're on that side of the road. This plan doesn't seem to show the pavements, but we can see that we're pretty good. So those are the corners of the buildings. That was the white line on the road. There are points here, that white line on the road, the corners of the buildings. So we're all looking good. And that's it, really. We'll just turn on the contour, see if that helps us in any way. Not the clearest view, but we can see our elevations seem to be correct. It's probably a little bit noisy. Yeah, we'll accept that that's accurate. Our camera with our 22.3 sensor size giving us a focal length of that. And again, all the dimensions here, the position seems to be in the right world coordinates. The only thing I would do now is Cinema4D isn't keen on having things so far from the origin, so I'd probably group everything and offset them nearer to the origin, but you should do that after you've brought in all your surveyed points and camera stuff from Syntheyes. But then, yes, once you've got it near the origin, things are a little bit more convenient for Cinema4D. And that's it. And we can check that our proposal is, our survey points are in the right position by adding a few cubes, just test that the scene is, the perspective is correct. So I've put a quick cube here, just this wall. And we can see that it's pretty much running along the top of, well, I say pretty much, it is accurate to the top of that wall. The verticals lining it nicely down there. So that's looking pretty good, and I've put in another one here as well, which is on the that slab back there, which again is lining it nicely. So there's that. And again, if we look at this in, say, perspective view, we can see that these points are all lined up properly. So that's good, and we took this a bit further forward. This is a proper job, so let's show the what we used in the end. Nice. So that's that view 2 there, with our proposal at the right elevation matched up with the site plan. And here's that building off in the distance, with the final view in the end looking like that. Before, after, before, after. So hopefully that'll show that that's an effective way of aligning the camera with the photograph. I should point out at this point that the main reason for doing this is so that you don't have to futz around in Cinema4D trying to accurately align the rotation of the camera with the points. Trying to rotate the camera to these particular rotations here could have you running around in circles. Using Syntheyes means that it takes care of all this micro adjustment, so that you don't have to. And that way you can guarantee that your placement of any proposal is accurate. Okay, that really is it. Thanks very much for watching. I hope some of this was useful. If you've got any comments, put them in the stuff down below. Yeah, goodbye.